Yeah, hi people. Today I want to show you just a quick video about collections. Let's create a project. We create a library and it's called collections, all right? We can open the project and we see we have the toml file with our package name, the dependencies, a git ignore, and our library file, lib.rs. Okay, we can remove the tests and this add function for now and just start with the basic collection types in Rust. So what do we have? The first thing is a const collection. So we can call it buffer const, an F32 with a size, and then we initialize it to 0. So what we have here is const memory. It's like a const array. And what this is doing is first it's globally available, but it will be copied into the positions where you use it. So it's not like it's just living here and when you use it, you will reference this variable. No, it's really like when you use it, it might get copied. It might not. Here we see the full array. That's 512 zeros. It might not get copied, but yeah, you have the possibility. So it might lead to increasing the size of your program, right? The other option we have is static global memory. And static, now let me write it first. Here you see there is no difference in the array. It's still like an array, but static just says it's guaranteed to have only one fixed location in memory, and you will always access that instead of copying the array to the positions where you use it. Okay, that has a nice feature. I mean, if you have one location in memory, you can also mutate it. So there is something like static mute. It is not safe to do it because it's global, but you can. Yeah, I mean, that's the biggest difference, right? But in general, so this is like a global variable really, and this is just a constant that will be placed in your code. In general, you should prefer this, like always use constants, and just when you need, use static memory. This could be because your array is really large and you don't want it to be copied in multiple locations, or because you want to mutate it, right? But in my tests, like I'm building an inference engine with a lot of weights, and there still const memory was faster, I guess, because it is used at the location and might be then treated like a normal array on the stack, while this might be in the read-only memory. But I'm not 100% sure about where it's stored in the binary. Okay, then we have the usual collections that we use in the program. So we create a function because those types we cannot just create globally. The first is the array. Yeah, the array is what we see here already. So we have 0.0512. You see here in the type hint, it's an F64 now by default. If you want to force it to F32, you could do this. Yeah, that works, but I don't care at the moment. So this is an array. As you see, the size here that we give it, so it's again, it's 512 zeros. The size is part of the type, so it's known at compile time, and that's why it can be allocated on the stack. And you can even like create this object in a real-time audio process. That's no problem. It doesn't allocate, it doesn't call a sys function or something. The second type is the vector. That looks the same, just with the vec keyword. Okay, and this is now allocated on the heap. It calls alloc, the system function, and that's why you shouldn't create this in a real-time audio process. You can still use vectors, that's no problem, but just don't allocate them or create them in a real-time process in your audio callback. Okay, how do we continue from here? We can reference this, like to move those collections around, like when we want to use it in a function, we reference them. What usually is happening if you reference an array is, I'll just call it here array ref. You reference by the end symbol. Okay, and what you see here is, okay, now we have a reference to a const array with a size of 512. Yeah, that works. The other thing is the vector ref, yeah, is end vector, and you see you have the end vec. So now that's a ref. That would work. Yeah, we can now build a function to where we want to do something without copying. Yeah, what in a real-time process is necessary, and if you care about performance, for example, here use vec. We call it vector, and we want to have the vec. Yeah. Now we say it's a vec f32 and we do something with it. Okay. Now we call it use vec and say end vector. Yeah. So this is no problem, that works, and you see now the type automatically changed to f32. So Rust is smart enough to know, oh, it's used here. If you now use it in an as well in an f64 function, it won't compile, yeah, but here it's smart enough to know, okay, you meant this f32 here. So this works, right? But now we cannot call this function with end array. And this is kind of unfortunate, right? Here we see mismatch types, expected end vec, found reference, and array. This is not very nice. That's why we can use slices in Rust. And I say slice here, and slices just look like this. So it's a bit like an array, yeah, but you see an array has the number here, so the size inside of the type. A slice doesn't have this number, the size in the type. So a slice doesn't care how large it is. It does not need to be known at compile time, right? The size. It's just a reference to an array. And what this really is underneath, it's like a structure. Yeah, we call it slice. That is just like the data. Yeah, this is the pointer. In this case, it's non-mutable, so a const pointer to f32, and it's a length. Yeah, so a slice is kind of this, nothing else. Okay, cool. We have the slice, but how do we use it? Yeah? You see, when we say use slice, suddenly it works. Okay, it changed to f32 because we wanted f32 here. But although end array gives you an end f32, end array gives you a reference to the array, here it's automatically transferred into the slice type. It's a different type, right? It's not the same. The same counts for the vector. So if we say use slice and vector, also the vector gets transformed into the slice. So all kinds of collections over f32, also our static buffer and our const buffer, can be implicitly converted into a slice. Yeah, you also have an explicit version. Yeah, if you say array dot, you will find the functions as slice and as mute slice. Yeah, returns a slice containing the entire array, equivalent to end s. Yeah. So there you see already the next hint. We can use this, what is the same, or even let's delete this. Or what it means is 0 and vector.length. Yeah, so we say we want to hand in the full array. Yeah, or you can say vector length -1. Then we don't hand in the last number. So yeah, that's basically how that works. I think this is really it's really good to know, yeah, that if we, maybe as I write it down here again, array slice, or just call it slice, yeah, array dot as slice, and the same for vector dot as slice. Yeah. I don't know how much Rust experience you have, but here you already see, cool, we can shadow variables. So from here, the lifetime of this ends and we can just overwrite it. So that's pretty nice in tests and so on to use that, or that you don't have to come up with new variable names all the time. Yeah, but you see here now end F32 and F32, so it's not the same type. I think that's really good to know, because sometimes I was getting really confused. Why is it not accepting it? But that's the reason, because a slice and an array reference is not the same. I hope I said it enough now. Okay. I have to think if there's something missing. I think we're good here. Let's continue from here in another session. Yeah, just maybe one word I wanted to say. As, in general, when you see the keyword as, at least in the standard library and also in many other libraries, as often means that the operation is cheap or for free, right? When you see into, yeah, or clone, or to vec, for example, yeah, that means it might be expensive. So here you see, vec. The toVec function is creating a new vector, so it's allocating new memory, while as slice is just giving us a reference. So as is often fine to use in a real-time audio process, while to is dangerous. Yeah, it can be. It's not a guarantee that it will allocate memory, right? But usually you should be more careful with to, and as is a good indicator for a cheap operation. Yeah. So much to the first collections lesson. When you wonder why this is yellow, it means it's never used. Yeah. If we just put the pub in front of it, it knows it's meant for outside of the library, so it won't complain anymore. That's the reason why I put pub here. All right. Then see you next time. I hope you're well, and have a good night. Bye bye.